Hello, my name is Matthew Blecka, and this presentation is about the debris and pollution of space. To start, space debris started around 1957 with the space race between Russia and the United States happening. And then further on into 1960, the fact that both countries were releasing so much rockets and satellites and prototypes they never like cleaned it all up, and so this led to those deteriorating and just kind of spreading around space. In the 70s to 80s, NASA predicted something called the Kessler syndrome, which predicted that debris will stem from collisions and explosions rather than new launches. What this means is that satellites that are already in the atmosphere and in space are more likely to explode from malfunctions or collide with each other due to a lack of gridding and managing the transportation of satellites and rockets. Today, the U.S. Space Force is starting to prioritize sustainable space and exploration, and NASA and SpaceX are starting to address these issues with space debris. So, the growing problem of space pollution is that we now approximately have 88,000 tons of debris in the orbit. And within the last 15 years, there have been the most ever space launches with things like SpaceX and NASA releasing so much, like with Mars and other observations of planets. And so a lot of these prototypes and missions that were sent out have started to collide and explode along with decommissioned vessels. So they all kind of just crash in or malfunction, and that spreads thousands, if not millions, of debris all around. Um, and as mentioned, the Kessler syndrome predicted this. Space debris in Earth's orbit. So there's three stages, or three perspectives, I guess. The low Earth orbit would be 1,000 kilometers below, so that would be what's closest to us on the crust, and that contains the largest concentration of debris, meaning there's the most debris closest to us. And the GEO, the geostationary orbit, is a clear view of the orbital pollution, which is what we can see here in this image, is that there's a lot of pollution around us, but we see a lot of those white dots closest to the Earth, showing the LEO. And polar perspective is observing the low Earth orbit from either one of the poles, being the North or the South Pole, and that's a unique way to see how much debris is there. Space debris, past, present, and future. So early measurements around, I think it was around the 50s to 60s when the space race was going on, there was only thousands, less than 1,000 pieces in the orbit. But now we're approximately at 35,000 pieces, which as mentioned earlier, weigh about 88,000 tons. Um, in the future, people are saying that, or experts are saying that debris could possibly reach 50,000 pieces by 2030, showing a steady incline of space debris and showing how this is a wicked problem. Um, Improvement efforts are from NASA, and some legislators are starting to realize that this is a serious issue for the Earth. NASA's space debris cleanup strategy, they have a few of them, but the main one that there's two main ones that they're going for. This one is around catching debris and changing the trajectory of some debris. So for instance, the smaller debris, they'd rather recycle, or not recycle, but take that back in to the Earth, and that would reduce collision, um, which would go against the Kessler syndrome. And then as for large debris, they can't really catch that and bring it in without it causing problems for the surface of the Earth. And so what they would do there would be change the trajectory, either by pushing it with a different satellite or space machine or lasers. And the biggest concern about this method is to not harm operators of these space machines. The orbital laser method, this one isn't from NASA, but I think it is something developed in Japan. And what they were saying is to just pretty much zap the debris to melt it, and then that would either help bring it back into the earth or it'll just burn up into atoms. The tug method, which was also by NASA, they their other idea was to catch the debris and guide it into Earth's atmosphere and control it to land at locations which might not harm people. However, there's controlled and uncontrolled. Sometimes they'll be able to successfully land the trajectory somewhere where there's not a lot of people or where it won't cause harm. But on other times, the uncontrolled descent might come and have it burning up into the atmosphere, which could cause problems for things like the ozone and climate change. So, to start with the legislation acts, this one has already been passed last year. It's called S40, 447. It's called the Orbits Act. And Congress mandated NASA and the Department of Commerce to collaborate on debris tracking. Um, During this, they're pretty much just trying to establish that no matter what, we need to figure out sustainability for space, and we need to stop having so much debris and pollution in space. Um, However, NASA stated that their biggest barrier is that they need funding and they need more assistance in order to figure out where all of this stuff is going. Um, Something that I thought about that might be good would be global legislation. If the United Nations regulated how much spacecraft each country can launch annually, this would help reduce the Kessler syndrome of newer space launches colliding or exploding with other spacecraft. And this would also just simply reduce the growth of space debris. Another recommendation I have is to put a quota down for these big space agencies like NASA and SpaceX. If they're continuously launching new aircraft or spacecraft, then there's more likely a chance of debris with all of the pollution in space. However, if they were assigned a set quota to have to remove, let's say, 1,000 tons every 6 months, then it would slowly reduce the debris going in and create kind of a deficit. So there would be more debris going out than in. And that would also just simply reduce the amount and the weight of debris and pollution we see in space. To conclude here, the importance of space debris, or the importance of the issue, is that space debris threatens the safety and sustainability of future space exploration. It's leading to a lot of potential issues and it makes space travel unsafe. As mentioned earlier, NASA emphasized that they need external funding, and that's why the Orbits Act kind of put the Department of Commerce and NASA together to help find funding for space debris and pollution. Some barriers we can see is funding, as mentioned. They have plans, but they're expensive and they can't put it into action yet or engineer these things that may actually help with space debris. Um, some personal recommendations I had is that legislators and space agencies need to clean up their own mess rather than leave it out. This would keep the atmosphere clean, and through this mandation, it would be a slow yet permanent solution. I think the Orbits Act was a really great way to start this, but there needs to be more legislation, as I mentioned earlier, like a quota or a limit to how many spacecraft can enter annually. And here are my references for all of this information. There's 2 slides for that. And these are all the picture references, but I also made sure to include links onto the pictures. And that's all I have for you guys. Thank you.